So far, we've talked about features that develop when lava escapes at the surface. But we also have volcanic features that develop inside or are intrusive igneous structures in our planet. We have intrusive igneous rocks that develop when we have magma very slowly cooling down and crystallizing deep beneath the surface. We only see these igneous intrusions when they've been exposed by uplift and erosion. So they've been pushed closer to the surface and the material on top of them have been eroded away. But when we're looking at the intrusive igneous forms, we want to look at their shape in order to give them a name. And these are either going to be tabular or massive. So with tabular, think about a tablet, like an iPad. This is going to be a relatively flat, thin layer. On the other hand, we can have a massive shape. And with this, think about just a handful of Play-Doh. It's going to be kind of bulbish in shape, but it can be whatever weird shape it wants to be. But we also want to look at whether these igneous intrusions are cutting across or are in between layers of the rocks that they're cutting into. So if they're cutting across multiple layers, we call them discordant. If they're within layers, just between them, we call them concordant. And we're going to get into this more on the next slide. When we're looking at those tabular intrusive bodies, the ones that are thin and flat like an iPad, the way that they develop is that magma is going to break or intrude into a weak zone of a pre-existing rock. And it's going to form two different types of igneous intrusions. And these are called dikes and sills. And their difference are whether they are cutting through layers or in between layers. So we see that dikes are discordant. This is what we see on the image on the left. It looks like a wall that is cutting down through a mountain. But instead, this is an igneous intrusion. It's where magma has cut through multiple layers of rocks, leaving a discordant igneous intrusion when it cooled and solidified. The other type of intrusive tabular body is called a sill. In this one, the magma is not breaking through layers, instead it breaks between layers. And I remember this one because it's a sill. It's as flat and horizontal as a windowsill. These are concordant. They're not breaking between rock layers, or they're not breaking through rock layers. They're laying in between individual layers. But one of my favorite types of intrusive igneous bodies is columnar jointing. This happens when we have magma cooling off and crystallizing. But as it cools and crystallizes, it shrinks into what are called columnar joints. Here we're going to see that it's going to form perfect columns that can form hundreds of feet thick columns of solid igneous rocks. If you watched Game of Thrones, this was really important in the later seasons. The image that we're looking at here is that Giant's Causeway in Ireland. It looks like it's just different paving blocks stacked together, but instead this is where magma cooled off into columns hundreds of millions of years ago. And our last type of igneous or intrusive igneous bodies are going to be very large in size. And these include batholiths, which are these felsic igneous bodies that are hundreds of miles long. These are going to make up entire mountain ranges. So if you've ever been to the Sierra Nevada mountain range in California, this is a batholith. It's igneous rocks that formed hundreds of millions of years ago, deep beneath the surface, that have been pushed up into mountain ranges. But we can also see a smaller area of igneous rock that formed deep under the surface that's called a stalk. These are similar, they formed in the same way, but they have very small surface exposure compared to a batholith.